Space is scary. Just think of the fact that if you were to take an ordinary person and leave them in space, they would die within 15 seconds from both lack of oxygen and extreme cold. But there are things in space that can kill you even before you get close enough. Black holes, for example. There's a lot of talk about them, but in fact, we still don't know much about these cosmic monsters. How do they form? What's inside them? Can they destroy the universe? And why do black holes sometimes have hair? We'll talk about this and other strange facts about black holes today. So watch this video and try not to fall into a black hole. The first question any curious person might ask is how black holes form. Well, like most things in space, they form from gas clouds. In particular, giant clouds of hydrogen and helium. Usually these clouds are around 100,000 light years across and contain a couple of trillion stars each. When such a cloud begins to collapse, gravity pulls the matter together. In the center, the density increases dramatically and a star is born. Our sun, for example, formed just like that. It was only when it ran out of hydrogen that it turned into a red giant, then shed its outer layers and turned into a white dwarf. But some stars are many times bigger than our sun, and after they exhaust their nuclear fuel, they turn into monsters with incredible density and gravity. This is how black holes are born. They're the final stage in the life of a massive star. The mass of a black hole can be several dozen or even hundreds of times greater than the mass of the sun. At the same time, their diameter is no more than several tens of kilometers. And this means that the matter in black holes is incredibly densely packed. For example, if you took a teaspoon of matter from the surface of a neutron star, which is already extremely dense, and squeezed it to the size of a proton, it would weigh several million tons. Now imagine squeezing the entire Earth to the size of a black hole and you will get something like that. A black hole is a region in space with gravity so strong that nothing, not even light, can escape its grasp. That's what makes black holes truly unique. All other celestial objects let light go around them, while black holes hold it back. If you watch a stream of light approaching a black hole, it will seem to slow down as if gravity is slowing it down. Then the light will seem to change direction, bending around the black hole. And finally, it'll disappear over the horizon of the black hole, which is called the event horizon. This happens because the gravitational force near the black hole is so strong that light can't escape it. Even though light doesn't have mass, it still experiences the effects of gravity. Light that falls into a black hole can never get out again. That's why black holes are also called inescapable. Once something crosses the event horizon, there's no turning back. Not even a photon can save you. In theory, one could somehow move around near the event horizon, but in practice, no one will survive such a journey. The closer you get to the event horizon, the stronger the gravitational pull becomes. A spaceship would be torn to pieces long before it got close to the point of no return. This process would be similar to what happens to a spaceship that gets too close to a neutron star. It would be stretched by tidal forces until it turns into spaghetti. This is exactly how Stephen Hawking and his colleagues calculated the possible fate of a spaceship trying to sneak into the event horizon of a black hole. By the way, this idea is brilliantly embodied in the movie Interstellar, where Matthew McConaughey's character enters a black hole and finds himself in another dimension. Although scientists don't know for sure whether this is really possible, it hasn't been ruled out. Maybe someone really managed to use a black hole to travel through time, or move to another place in the universe. But this remains only speculation for now. By the way, speaking of Interstellar, do you remember the scene where Matthew McConaughey's character steps out of the black hole and suddenly finds himself surrounded by water? In fact, nothing like that would happen. In reality, nothing can come out of a black hole because nothing can escape the gravitational pull of a black hole. Even if it did, it wouldn't find anything interesting behind the event horizon. The thing is, despite the fact that black holes aren't visible, they still have surfaces. It's called the event horizon. It's not quite a physical boundary, more like an area beyond which nothing can return. Once something crosses the event horizon, it can never be seen again. The reason for this is that the gravitational pull near a black hole is so strong that even light can't escape it. So if you were to look behind a black hole, you would see nothing. And if you tried to get as close to it as possible, you would simply be pulled into it. You would fall into a place where gravity is thousands, millions, billions times greater than on Earth. At some point, the gravity would become so strong that it would tear your body to pieces. You would be completely crushed or stretched. Even atoms couldn't withstand such force. They would disintegrate and turn into a puddle of elementary particles. In a word, if you fell into a black hole, you wouldn't survive. But black holes are not only dangerous, they're also very strange. For example, they can rotate. Most likely all black holes rotate at least a little, but there are also extremely rapidly rotating ones. These are so-called quasi-periodic black holes. Imagine a black hole the size of a pinhead rotating at almost the speed of light. This means that its equatorial velocity would be about 30,000 kilometers per second. Such a black hole generates enormous energy, probably several tens of billions of times the power of the sun. Scientists believe that such black holes can accelerate charged particles to huge speeds. The hot plasma streams emanating from them can reach speeds of up to 40% the speed of light. Some astronomers even believe that quasars may play a role in solving one of the biggest mysteries of modern astrophysics: the acceleration of the expansion of the universe. What does it mean? You may ask. Well, here's the thing. About 20 years ago, scientists made a shocking discovery. They found out that the expansion of the universe isn't slowing down as it should due to gravity, but is even speeding up, as if some invisible hand is pushing everything away from everything else. What kind of force could it be? One of the versions, although very controversial, is that it's the energy of quasars. These strange black holes could be the engines that drive the expansion of the universe. Another strange property of black holes is that they can have hair. No, this isn't a joke. In 1971, a scientist named John Archibald Wheeler coined the term hair just like that to describe the possible state of black holes. It wasn't a very scientific term, but the picture he painted was accurate. It turns out that black holes aren't smooth and featureless as one might assume, but are covered with some kind of fuzz. But what is it exactly? It turns out that black holes can have electric charge and spin, and this is manifested in electromagnetic and gravitational fields. Moreover, the strength of these fields can extend far beyond the event horizon. It's because all black holes are surrounded by an accretion disk. Matter falling onto a black hole heats up to millions of degrees and emits powerful X-rays. The fields generated by the black hole and the accretion disk twist and turn, creating some kind of a hairy crown around the black hole. This is what Wheeler meant when he came up with the term hair. But it's not just a pretty picture. The study of these space hairs can help us understand what's inside a black hole. Unfortunately, there's only one way to find out what's inside a black hole: by falling into it yourself. Or maybe there is another way. After all, black holes emit radiation. This radiation is named after John Hawking, who calculated its intensity. Yes, it turns out that black holes aren't entirely black. Hawking showed that the radiation emitted by a black hole depends on its mass and temperature. The higher the mass, the lower the temperature and the weaker the radiation. In theory, this radiation could be detected with special devices. Unfortunately, the temperature of a stellar black hole is too low for such a device to be built. But in 1970, scientists discovered pulsars with extremely high temperatures. Perhaps they could be used to test Hawking's prediction, but no one has succeeded yet. Maybe black holes are not as terrible as they seem. Maybe they can be friends. If you want to learn more about what's going on in space, check out our videos about mysterious space signals. Have you ever heard of the wow signal? You'll find out in this video.